the problem which we'll be doing right now. And so let's say this is something we'll do first, and then we go ahead. So all of you get cracking on this problem, and let's see how many of you are able to do this. All of you who are joining late, I have sent a problem in the group. You have to solve that problem first, and then we talk about the solution. How many of you are doing it? Please raise your hand. Shubhangi, Yukta, Nayak. Only three people have raised the hand. What's happening with the other people? I see so many other people are there online, but only three people have raised the hand. I want other people also to get involved and start working on this problem. Then I'll talk about the solution of this. So, if you have sorted out the first part, anyone who's done the first part, it should. And I also would like to see hands of all those people who have not understood it, how to do it, because you have to speak out over here. Because otherwise, I will be in misconception that you people know it, and I might miss out the basics. Okay, so that's important that we do this question.
Excuse me, sir.
Yeah, yeah,
Sir, can you
Shubhangi.
please share the table again? It's
Okay,
not.
I'll send it in the WhatsApp group.
Okay.
See, I tell you, this course is not at all, sir. What do we have to do after? I mean, what do you have to do after getting the value from the table? You have to solve this problem. What is the chance of obtaining a birth weight of 141 pounds or heavier when the sampling birth records at random? So you have to find out this value. Have you found out this value, Varun? 0.99305. No, no, that's not the answer. Anyone else who's done it? Okay, let me do the first part. Then second part you people do. Okay. So the birth weights of population are normally distributed with mean is given as 109 and standard deviation is given as 13. Okay. What is the chance of obtaining a birth weight of, so it is normally distributed. What is the chance of obtaining a birth weight of 141 Oz? So this is the mean 109 and 141 is over here or heavier. So we want this area, right? 141 or more than 141 when sampling birth records at random. So what I want to find out probability that x is greater than 141. Okay. Now we need to map x into standard normal distribution. So we need to find out the value of z. That is x minus mu by sigma. Standard normal variate value we find out corresponding to 141. So 141 minus 109 divided by sigma is 13. What do we get? We get 2.46. 2.46. Okay. So once we get 2.46, we can find out in the normal distribution table what is this area. Now we write probability that z is greater than 2.46. Can you tell me what is that area? Now let me go to the table and I'll. So corresponding to 2.46 we want to see. Okay. So we go here in the positive side 2.46. This is 2.4 over here and 6 is 2.46. So this is what we are getting, 0.99305. Okay, so we write that here. It's 1 minus 0.99305. Why 1 minus? Because this table is telling the area. If you look at this table, it is starting with very small value over here. That is, this is on the left side of the mean, and it goes up to 0, which is at the mean. At mean, it is zero point 0.5, and zero point 0.5 greater than, if you go towards the right side, it's more than zero point 0.5. So the area which it is this table is covering is somewhat like this. So this, for any value of z, it is telling the area from left to right. So from left to right, the area is 0.99305, but we are actually interested in this area for this problem. So this will be 1 minus 0.99305. What's that value? So we subtract it,
So 0.00695.
0.00695. Or if we multiply it with 100, we get 0.69%. Okay. Any doubts? Anyone's having any doubt in this? Yes, anyone? Okay, so now you do the second part. What is the chance of obtaining a birth weight of 120 or lighter? So 120 or lighter would mean somewhat like this. So this is your mean. Mean is 109, and they are asking 120 or lighter. So 120 is this. So anything less than 120. So they want to find out probability that x is less than 120. Okay. So we find out the value of z corresponding to 120. What is that value?
0.846.
0.846. Now we look into the normal distribution table where is 0.0846. So 0.0846. So we see zero point 0.8 is here. So this was 0.78814. 0.8416. 0.84. We will look across here. This is the value which we point 79955. We write that over here. 0.79955 is that area. I mean, we can write this probability that z is less than 120. This is that area. Okay. Or 79.955%. No doubts? Can we go ahead? So we have done
Yes,
both
sir.
the questions. Okay, now we come to a very important part which is called central limit theorem. The central limit theorem, which basically means that the word is normal. Word is normal means your all across the world, the natural things or the things which are happening, they follow normal distribution. Why? Let's see that. So there is a probability distribution which we have already talked about. There's another term called sampling distribution. Sampling distribution. So in sampling distribution, uh, we say, let's say this is a population distribution, like population of triple IT students. So it is finite, right? You agree or not?
Yes, sir.
Yes.
Population of existing triple IT students. How many students may be there? Any guess?
100 to 800.
Okay, around 800 students. Okay, so their height, let's say this is their height. So their height is normally distributed with mean and standard deviation sigma. Now, from 800, I can't sample all the 800, but I want to know that how many of you take supplements for height? How many? What's your protein intake? I just want to know per gram. Okay, on a given. So I do sampling. I can't go and talk to every one of you because many of you are not present in the campus. So I take random sample of 80 people, and I plot their distribution. So this is of 800 people. This distribution, and this distribution is of 80 people. It is a sample. We call it as a sampling distribution. This is a sampling distribution. Okay. And this sampling distribution would be having parameters mu and standard deviation as sigma by root 80. So if this is sigma for population, this will be sigma by root 80 for sample. That means it's going to show lesser standard deviation. Why do you think so? I mean, logically speaking, this is coming from statistics that the sampling distribution will have the for any population, the corresponding sampling distribution will have lesser standard deviation. Can you tell? Can anyone guess why? And we can also see why lesser because see the points are much closer in this, and while in population it is spread out. So why do you think sampling distribution has a lesser standard deviation than the population distribution? Anyone? See, it's quite simple. The more people you take, the more variation you are accounting for. Okay, if you take 800 people, definitely you can think that you will find out more variation in the height across because here you are taking all the variation which is existing, and here you are just taking a sample. There is a good chance that it is not covering all the variation. Like it is quite possible that you got three very tall guys, like 6 foot 5 inches, in your batch, and somehow they are absent or they are not covered in this sample because the outliers or the extreme points are missed out generally in the sample. It's not possible कि वो दोनों तीनों लड़के जो सबसे लंबे हैं वो इस 80 सैंपल में आ जाएंगे. Okay, so there is a good chance that they might be left out. So since the outliers or extreme values are generally missed out, the probability of missing out of the extreme values is pretty large when you are taking out a sample. Then in that case, because of that, the standard deviation is lesser for a sampling distribution. So the important fact which comes out of central limit theorem is that the if the population is normally distributed, the sampling distribution will also be normally distributed for any sample size. Okay, but now let's say you got another scenario. Like 80 samples are there, so I draw 100 samples of students with replacement from the population of 800 students. Are you getting what I'm saying? There are 800 students, okay, in triple IT. So what I do is I draw a sample of 30 students each with replacement. samples with replacement from the population. And how many? Let's say I draw 100 such samples. Okay. So how many people have I sampled? Each sample is having 30 students. So 100 samples will have how many?
3000.
Yeah. So, and I plot them like this. Let's say, so sample one, the distribution is somewhat like this. This is one, sample number one. Sample number two, around the mean, the distribution is like this. Okay. This is sample number two. Sample number three, its distribution is, let's say, like this. So, like this, I have 100 samples. So I can find out x1 bar, x2 bar, x3 bar, and x100 bar. I can find out all these means. Yes or no?
Yes, sir.
Are you getting what I'm saying? How many of you are understanding what I'm saying? Please raise hand if you have understood what I'm talking about. Let me see. Only Varun Saini, Yukta Parikh, and Shubhangi Garg have understood. What happened to other people? Ashish Saxena, are you present or not? Keshav, are you present? These
Yes,
are.
sir. Yes.
So, did you understand what I said?
Yes, sir.
Can you repeat what I've said? Say, if you have understood, tell me. That means you have not understood, or you are busy in watching something or eating food and whatever you are doing right now. Madhusudan, are you present? Srija,
Yes, sir.
can you tell Srija what we are talking about?
Sir, I got confused in the last third step. I was thinking about that.
So ask me back where you got confused.
After X2, sir.
So
X2
after
bar.
X, what is x2 bar? What is x2 bar? Can you tell?
Sir, you said that we are taking 30 in each sample, so we got 3000 samples in each,
Uh,
right? Then
total total 3000 units we've got. I mean, you should
units,
not worry
sir.
about 3000, leave that. So we've taken 100 samples. In each sample 30 students are there, and their
Okay.
heights we have plotted, and we've got these curves. Okay, their distribution of height is like this. Each, getting it?
Yes, sir.
So for 100 samples, we've got different distributions. Okay,
Yes.
now with these 100 distributions, we've got 100 means. Now I can make a frequency distribution for these 100 means like this, let's say. So I can make a frequency distribution or how these means are distributed. So these means will be perfectly normally distributed. This is the central limit theorem. That is, here it will be x double bar. On x-axis you will be plotting x bar. So on x-axis, if you are plotting x bar, getting it? This is very important. On x-axis, if you are plotting x bar, that is for 100 different means which you have got for 100 different samples. If you plot this x bar, you will get a perfect normal distribution, or you will get a normal distribution. That means of means, or you can say means of different samples are normally distributed. That's why word is normal. Okay, so this is the meaning of center limit theorem. So it says that irrespective of whatever distribution is irrespective of whatever distribution individual 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 random variable follows mean of all the distributions together will follow normal distribution. I hope you understand this. So this is the implication of central limit theorem. And using this only, the whole theory of statistical quality control is built upon. So if a random sample of n observation is selected from a population, any population of any distribution, then if n is sufficiently large, if n is sufficiently large, the sampling distribution of x bar will be approximately normal. Okay. I repeat again, if a random sample of n observation is selected from a population, okay, and if n is sufficiently large, the sampling distribution of x bar will be approximately normal. So we say the larger the sample size, the more closer it will be to the normal approximation to the sampling distribution of x bar. Okay, so x bar follows normal distribution. X bar follows normal distribution. Any doubts? So, like in quality control, we select random samples of size n. We can model the distribution of these sample means with a probability model, which has normal distribution with mean and standard deviation sigma by root n. Okay. Now, with this assumption, we can do that, and it is normally distributed when n is greater than 30, then no problem. If your number of samples, that's why no, while grading is done, if your section has less than 30 students, we don't go for relative grading, we go for absolute grading. How many of you know that? Is there any elective in which less than 30 students are there? Yes. Have you people done any elective in which less than 30 students are there registered?
No, sir.
Okay, so that's why you always get relative grading. No matter how bad you do together, if you are doing bad, someone is bound to get AA plus, I mean double A. But if it is less than 30, then you people are in trouble. Okay, so I'll repeat that again. I'll summarize whatever I've talked about. So we talk about population first. So if population has mean and standard deviation sigma, and shape of the unknown, let's say shape or distribution is unknown of the population, we don't know how distribution of the population is, then we select a random sample of size n from this population, then the sampling distribution of n would be mu and sigma by root n, and it will be normally distributed. And if n is greater than 30, it is very good, or we can comfortably assume we can comfortably assume normal distribution of x bar. This is the sampling distribution. Okay, always remember the shape of the sampling distribution is approximately normal. Okay. Similarly, binomial distribution. How many of you know binomial distribution? Do you know binomial distribution, guys? Have you heard about it? Of course, you would have heard about it, but you're too busy to tell that.
Yes, sir. Got it.
So in binomial distribution, we have Bernoulli trials in which, let's say P is the probability. Let's say winning, and you toss a coin, and probability of getting a head or a tail is zero point 0.5 in that case if it's an unbiased coin. So we say if I get head, it is a success. Okay, if I get a tail, that is a failure. So if a random sample of n observation is selected from population and x successes are observed, that is, if I toss coin n times, if I toss a coin n times, okay, and out of n, x successes are there, like that is heads. If I get x heads, then, and if n is sufficiently large, that is greater than 30 times I've done this, the sampling distribution of proportion, that is p, that is proportion of success, we can say, will also be normally distributed. Will also be normally distributed. That proportion of success, where p hat is representing average proportion of success. Okay. Then in this case, the mean and the standard deviation would be, it is normally distributed. So mean will be p, and standard deviation will be given by p 1 minus p by root n. This is how we say if it's a Bernoulli trial, right? That is win and lose, or there are many such situations, defective or not defective. Getting it? So there we will use this concept. So in this case, n into p should be greater than 10, and n into q, that is 1 minus p, should also be greater than 10. So if n into p is greater than 10, we say the sample is large enough. Okay, so this is the guideline for Bernoulli trials. So let's say we do a problem. So the probability distribution of 6-month income of account executives has mean. The 6 months income has a mean of $20,000 and standard deviation of $5,000. Okay. A single executive's income is 20,000. If a single executive's income is 20,000, can it be said that this executive income exceeds 50% of all account executive incomes? So it means that this is mean 6 month salary. Now we pick a random sample from these executives and say this person's salary is $20,000. Can we say that, I'm removing it. Can we say that this guy which I have just picked, this person which I have just picked, is having salary greater than 50% of the people in the company? Give me the answer. Did you understand what I'm saying? The probability distribution of 6 month incomes of six of account executives has mean of $20,000 and standard deviation of $5,000. Now, a single executive income is $20,000. Can it be said that this executive income exceeds 50% of all account executive incomes?
I think, sir, we cannot say this
Why?
because, sir, because it's exactly the mean 20,000. That is, um, we can say that not greater than 50%, equal to 50%.
इक्वल टू तो बोल ही नहीं सकते ना, कंटिन्यूस डिस्ट्रीब्यूशन है. एनीवे जो मैंने बोला उसमें कहीं पे मैंने नॉर्मल डिस्ट्रीब्यूशन बोला? अगर if in the question I would have said that the probability distribution of the incomes is normally distributed, then that would have meant कि ये normally distributed है तो mean बीच में है बिल्कुल 50% here and 50% here. Okay, but I did not say it is normally distributed. I simply said the probability distribution है, उसका mean और standard deviation ये है. So it could have been any sort of distribution. ये भी हो सकता था. तो इसका मीन यहाँ पे है, तो जरूरी थोड़ी है कि ये भी 50% होगा, ये भी होगा. ये तो कहीं लिखा नहीं है कि सिमेट्रिकल है. तो आप नहीं बोल सकते कि ये स्टेटमेंट ट्रू है. ठीक है. We go to second question now. Second question is, now n is equal to 64. Let's say we take 64 employees. 64 account executives are randomly selected. What is the probability that the sample mean exceeds? What is the probability that sample mean x bar is greater than 20,500? Okay, of these 64 people who have been taken. So first thing, it is a sampling distribution. Why? Because it is not the whole, it is not all the executives. Okay, this question is not coming for all the executive, but the question is coming for a sample of 64 executives. Okay, and it is also given that this is not. Now here, do I need to specify that it is a normal distribution? I repeat the question. N is equal to 64 और 64 account executives are randomly selected. अभी भी हमने कहीं पे ये नहीं बोला है normally distributed है. What is the probability that the sample mean exceeds $20,500? So here, do I need to specify कि ये normal distribution है?
No,
No,
sir.
sir.
Why?
Sir, because in sampling theorem we can assume it.
Yeah, because of the central limit theorem, not sampling theorem, because of the central limit theorem, and we see that n is greater than 30. So we can clearly assume that it is a normally, sample means are normally distributed. That means यहाँ पे जो x bar होगा, x axis पे क्या है, x bar है. Okay, and 20,000 यहाँ पे ये बोला हुआ है कि ये mean है. Sample, I mean, actually, see, one confusion you might have. Population mean कितना दे रखा है? Mu is 20,000. And sample का जो estimate होता है, तो mu and sigma होता है, right? And sample के लिए क्या होता है? Same चीज होती है, जो x bar is equal to mu for even sample as well. X bar equal to mu for sample as well. Okay, so जो मीन है, जो सैम्पलिंग डिस्ट्रीब्यूशन का मीन है, वो भी $20,000 ही होगा. इट इज बिकॉज ऑफ, आई मीन, इट कैन बी प्रूवन, स्टैटिस्टिक्स ने प्रूव किया है, बट जो सिग्मा होगा वो सिग्मा बाय रूट एन होगा. ये म्यू और सिग्मा ही रहेंगे पॉपुलेशन के लिए, बट सैंपल के लिए म्यू एंड सिग्मा बाय रूट एन हो जाते हैं. ओके. So, what we are supposed to find out? We have to find out this area. Okay. Now, how do I find out this area? I need to calculate Ex. We say Ex bar is equal to mu. That is expected value of X bar is mu. Expected क्यों? क्योंकि हमने पूरी पॉपुलेशन तो नहीं मेजर करी है, बट जो एक्सपेक्टेड वैल्यू होती है सैंपल मीन की, वो पॉपुलेशन मीन ही होती है. अगर आपको पहले से पॉपुलेशन मीन पता है तो नो प्रॉब्लम इन दैट. सो विच इज $20,000. But standard deviation, expected value of standard deviation, or expected value of sigma, I can say over right here. Expected value of sigma will be sigma by root n. ये चीज आपको बहुत ध्यान रखनी है. You should be able to spot कि ये सैम्पलिंग डिस्ट्रीब्यूशन की बात हो रही है कि पॉपुलेशन डिस्ट्रीब्यूशन की बात हो रही है. Okay, then it will be 5,000 divided by 64, which is equal to 625. Okay. Now, because of the central limit theorem, it is normally distributed with mean $20,000. I mean mean 20,000 and standard deviation 625. Here you have to write, always in the exam you will have to write because of or by central limit theorem. This is applicable. Okay. Now, next thing is what we have to do is we have to find out probability that X bar is greater than 20,500, which will be equal to probability that Z is greater than some value. Okay. So let's find out that value of Z, which we are interested in. So let's say this is area which we are interested in. So here Z will be equal to X bar minus mu sigma by root n. Okay. So here X bar is 20,500 minus mu is 20,000 divided by sigma by root n is 625. Okay. So what do we get?
So 0.8.
0.8. Okay. So quickly tell me, so Z is greater than 0.8. What is that value?
So 0.21186.
0.2119, I think.
Yes,
86.
around that.
Okay.
Yes.
So we get that answer. Any doubts in this? यहाँ पे आप क्या लोग आप लोग गलती क्या करते हैं? आप यहाँ पे सिग्मा बाय रूट एन की जगह सिग्मा लिख देते हैं. ये पॉपुलेशन के लिए थोड़ी हो रहा है, इधर सैंपल के लिए हो रहा है. So you have to be careful in doing that. Okay. Now I'm sending another question. Quickly do that question and send photo of that. All of you do this problem on piece of paper with the make diagram for sure, and then send me the photo. Come on, it should not take that much time to do it. Should not take that much time. Please. Okay, raise hand. How many of you are doing it? Let me see. Only one person is doing it. What happened to others? Only Shubhangi seems to be doing it. Okay.
Sir, I have also.
Okay, okay. Rupinder, Shrija, Varun, Shubhangi. Okay. Okay, Varun has sent answer, but it is not matching. So let's see, Varun. Okay, so let me see. Has anyone sent the answer? But at least Varun has done it here. Okay, so let me do this question. You might be finding it a bit of difficulty. It is somewhat reverse. So battery life of certain product is normally distributed with mean with 20, and so this is the population mean and the standard deviation which is given. Guarantee average battery life in case of 24 units exceeds 16 hours. So 24 units, 24 samples are taken, and it is found that uh, these 24 units have exceeded 16 hours of battery life. This is 20 over here, and this is 16 over here. So find the probability that a randomly selected case meets the guarantee. So guarantee means that more than 16 hours. So I have to find out probability that a randomly selected sample of 24 units has greater life than 16 hours. That's what I want to find out. Okay. So this area I want to find out. Okay. So corresponding to this, the z value is, now here this is 16, right? So 16 minus mu is 20 divided by sigma by root n. So sigma is 10 divided by root n is 24. So this value, what you get? What is the value? Minus 1.96. Minus 1.96. Okay. Now corresponding to minus 1.96, look into the normal distribution table. Corresponding to minus 1.96 is over here, 1.9 and 6. 0.025. So that means the area which is given in the is from left to right, which is 0.025. This area is given, but we are interested in probability that x bar is greater than 16. So that will be 1 minus 0.025, which will be equal to 0.9750. Any doubts in this? Any doubts?
No, sir.
So this is the probability that we want to find out. Now we'll continue our lecture in the next week. Okay then, I conclude here.
Thank you, sir.
Thank you, sir.
Okay.